Thank you for joining us for today's Partner Learning Media Web Conference, Fast Track Dynamics 365 for Finance and Operations Enterprise Edition Tech Talk. And today's topic is the extension programming model. And with that, we've got Zach Greenvoss joining us here as our presenter. He's a senior R&D solution architect. And handling Q&A, we've got Kirill Val as well. And with that, you guys now have the floor. Thanks for joining us.
All right. Thank you, Otto. Hello, everyone, and welcome to this Tech Talk on Extensibility. My name is Zach Greenvoss. I'm a solution architect with Microsoft. Today, I'm going to be walking you through the various extensibility options available in Dynamics 365 for operations. We'll be talking about the overall plans to seal the application, which hopefully will not be a surprise to you, but we will walk through the specific plans. Then we will go over what extensions are and how they fit into the bigger picture of application models and packages. Next, we will dive deep into the various options available and take a fairly exhaustive look at the extensibility features. This will primarily be at the metadata level. The last section will dive into the class augmentation features of X++ and how some of the new features, such as chain of command, can be used to remove overlayering completely. So let's take a look at what we mean when we are talking about app sealing. AX, from early on through 2012 and into the AX7 release, has always allowed customers and partners to have a high level of customization of the source code and business logic. This was typically achieved through a technique called overlayering, wherein partners made changes to the Microsoft-provided source code directly in line to the existing code. While very useful and a boon to partners and customers looking for the ultimate flexibility in defining business processes, it has proven to be very difficult to manage the upgrade process for code that has been customized in this way. Updating the code to get a hotfix or uptake an ISV solution often involves an entire new project with costly development fees that is prone to errors and additional bugs. Ultimately, this causes our customers to not take important updates and hotfixes. This is especially challenging in the cloud world, where we need to issue updates at a faster pace. The ultimate goal for all of this is to enable our customers to have a true cloud solution that provides a platform that gives easier and less expensive upgrades and updates. The bridge that will enable this transformation to happen is extensions. By expanding the extension capabilities in Dynamics 365 for operations, we are enabling partners and customers to continue to build vertical solutions that add value, but that do not directly interact with the Microsoft source code in a way that makes it difficult to upgrade the solution. Here's another view of the same goals. The ultimate goal is to improve the quality of the solution and allow customers to have a continuously updated and improving platform. For Microsoft partners, they should be confident that the solutions they build will continue to work and bring value to their customers, no matter what updates and changes are made to the core product. Some additional benefits we see with moving to extension-based customizations are looser coupling and improved testability in both Microsoft and partner solutions. Also, by moving code away from the larger Microsoft models, partners can enjoy much faster build times and a more efficient application development lifecycle. Finally, the actual distribution of solutions is more lightweight and streamlined in this model. I just want to take a moment here to ensure we are all on the same page. The example on the left is what I mean when talking about overlayering. There is the core application suite provided by Microsoft, which has been directly extended by multiple ISV solutions and a partner VAR solution to tie it all together. This entire set of code is compiled into the final application assembly, and any changes or hotfixes need to be merged across all four solutions. The extension-based solution on the right is where we are moving towards. In this, the Microsoft-provided application suite assembly is isolated from changes and is only modified directly by Microsoft-provided hotfixes. The ISV solutions and the VAR solution are also deployed and maintained as discrete assemblies. Extensions to the models are hosted internally to these assemblies through the techniques we will discuss in this Tech Talk. This model is easier to update and able to handle changes to the solution over time in a more agile and fluid way, as the interfaces are well defined and any components can be swapped out or upgraded when it makes sense for the business needs. I also want to give everyone a clear idea on the plans moving forward for Microsoft. This has been published and talked about a lot, so it should be a review. The application platform and foundation were hard sealed last year, meaning no overlayering is allowed. Some of the application core models, such as the dimensions and cost accounting, were soft sealed in the spring release. Soft seal means overlayering is still allowed, but a compile warning will be issued warning the developer that soon this will be sealed and they should move their overlayering customizations to extensions. In that vein, the large application suite model, where the majority of the code and customizations reside, will be soft sealed in the fall release this year. Moving forward, several of the App Suite core models will be hard sealed in the fall. We'll be publishing a complete list of the models shortly. Important to note, however, is that the application suite will only be soft sealed in the fall. This will be the last release where it is possible to overlayer the application. Come the spring 2018 release, we will be hard sealing all models, and the only option to extend the application will be to use the extensibility features provided. Now that we have a good idea of the general roadmap moving forward and how important it is to embrace the extensibility features, let's take a look at exactly what those features are. At the core level, an extension is just something that augments or adds to the capabilities of another object. As discussed, these additions can exist in a separate model entirely, thus allowing partners and ISVs to keep their changes isolated from each other and Microsoft. We will be discussing these capabilities in detail, the ability to add new model elements to the solution, and the ability to modify or augment existing model elements. This will also be referred to as metadata extensibility, as you are modifying the metadata of the various elements in the solution. Finally, we will spend quite a bit of time exploring the underpinnings of how to augment source code. There are several options here, each of which can help address some of the capabilities that overlayering provided. An extension model provides the ability to add any of the elements that are available in a typical Dynamics 365 solution. So new classes, forms, tables, and EDTs can all be added and managed as a complete separate solution built on top of Dynamics 365. If possible, this should always be your first choice. If you can isolate your development and only produce a solution that is additive in nature to the core product, you will be safe from any core product changes and ISV interactions. Obviously, this is not realistic for most solutions, but when possible, this should be examined as your first choice. In terms of metadata extensibility, the things you can change really depend on the type of model element you are augmenting. We will walk through what is possible, but in general, the types of changes you can make are adding new fields or UI elements, hiding and modifying existing UI elements, and adding data sources and enum values. Note that by and large, this is still a fairly additive list, though there are ways to make changes to the base elements. From the X++ side, there are several ways to hook into the base application and render code. Through some powerful extension capabilities added to X++, we can add methods and state to existing classes, and we have the ability to hook into a wide range of framework events and delegates. This list continues to grow with each release as we expose more of the system to this model. We are also working hard to refactor any object model that requires overlayering, for example, to add derived classes into a plugin-based solution, which means you can add new classes without touching the base code. Finally, we have the powerful new capability to write code that can wrap the base Microsoft code and update and change the state of the system as well as the input and output values. This plus delegates will be the core technology that allows you to replace the X++ overlayering. Yet it is completely ISV and upgrade safe and allows multiple partners to participate in extensions without adversely impacting the upgrade story. It's important that we understand the relationship between packages and models. This is a classic diagram that should be familiar to anyone coming from AX 2012. Basically, the package is a unit of compilation. Everything under a package is compiled into a single assembly. While layers are becoming less and less of a concern, they still exist, but more importantly is the fact that one-to-many models exist within a package. A model should represent some sort of logical solution. If you were to view the physical layout of the files on your developer machine, note that the directory might be different depending on the type of developer machine provisioned, you would see the packages and models represented like this. The top-level directories are the packages, and they can contain one-to-many model directories. Note how the large application suite package contains many models, including the primary one, Foundation, which is where the majority of the Microsoft code resides. When you execute a model build from Visual Studio, you are actually building one or more top-level packages, which is what this dialog is showing you. You can see each of the models that are contained within a package in a comma-separated list. This is important to understand because when you are creating a new model, you will have a choice to create it in a separate package, which means you are creating an extension model and will have to use the features discussed in this talk. Or you are creating a model in an existing package. This means you are overlayering and will have access to the classic Dynamics AX overlayering features. However, this functionality is being deprecated, as we discussed. Note the relationship diagram on the right. The dev stuff extensions is an extension package with a single model that can build extensible solutions for any referenced model. The ISV legacy overlayer model hosted inside the application suite package is an overlayer-based model and will allow for overlayer customization of the models within the application suite. However, this is exactly what will be disabled come the spring 2018 release. The next section of this talk will be a deep dive into the metadata extensibility features of the spring release and platform update 11. Some of this might go fairly quick as there is a lot to cover, so I encourage you to utilize the recording of this talk and go back to review specific areas in more detail. First, we'll take a look at what is possible with form extensions. Forms provide a rich set of metadata extensibility. It is possible to add new controls to a base form through extensions, including the ability to disable or hide existing controls. This is how some partners are customizing certain elements that might not otherwise be extensible. They will hide that section of the UI and add their own controls into the solution. There is some basic UI manipulation you can do, and you have the ability to add entirely new data sources to the form, which then allow you to make use of that new data. This data source can be from the base application or a new table added as part of your extension package. To create a form metadata extension, you simply have to find the form you want to extend, right-click, and select the Create Extension. Assuming you have a project already defined in an extension model, this will be added to the project with the default name of formName.extension. Note that we highly recommend you change this name, as otherwise you might run into a naming conflict at runtime with other extension assemblies added to the mix. The full name must be unique at runtime. We recommend the naming convention of a unique prefix before the extension suffix. You can see in this example that I have added a new data source to the list of data sources. Note that when I open a form extension, I see all of the base properties, but those are grayed out, indicating they cannot be directly modified. On the right side, you can see that I've added a new tab page to the tab controls in this page, which will be connected to the new data source I added to this form. Here you can see I've selected an existing group from the base form, and I can update several metadata properties in the editor. In my example, I have changed each of them to be non-visible. The properties that support editing via extensions are active in the property window. You can see the fields such as caption, enabled, country region codes, and help text there. So you can add, modify, and even hide UI elements. But much of what our partner solutions need to be able to do is access the rich eventing and object models behind the forms. In this, you'll be using the various code augmentation features in an extension project. Forms provide several layers of events, from the form itself to the data sources and the controls. Some forms could also support custom delegates raised from X++ code as well. All of these are capable of hooking into via your extensions. We have all of the various events documented at the different layers on our docs site. Many of these events have a preceding event and a succeeding event, but not all. When we do have both events, the preceding event will end in ing and the succeeding event will end in ed. Depending on exactly what you are trying to accomplish with your extension will determine exactly what event to hook into. To hook into a form event, simply expand the Events node in the designer and select the Copy Event Handler method menu item. This will place the event handler code into your clipboard for pasting into a class. Next, paste this code into a new event handler class located within your extension project. We will talk about this in more detail later, but this code does not need to live within a class that is specifically extending the form itself. The attribute is what ties the event handler to the event publisher. This code can exist within any class in the system. From within this event handler code, you have access to the original form and can write code that you typically might have written directly as an overlayer within the form itself. Another option you have, depending on the methods that are exposed on the form base class, is to augment the form methods themselves. One way to do this is to right-click a method and select the pre or post event handler option. This will do something very similar to what we saw previously, copying a boilerplate version of the method handler to the clipboard. This code can then be pasted into an event handler class. Note that there are some limitations to these pre and post event handlers. All parameters and return values are processed through the XPP pre-post args object, and you only have external or public access to the underlying object. So it is very good for notifications or updating external systems, but it can sometimes prove challenging to make direct modifications to the internal state of the form itself from here. A more powerful feature available in Platform Update 9 and higher is to utilize the chain of command technique. This allows you to wrap methods in your own logic, which provides you the ability to write that same pre and post event handlers, as well as gives you access to protected member variables and methods. In general, we see the chain of command functionality as a superset of the pre and post event handlers. Here's an example of an extension class on the sales table form, where we are wrapping the update design method. Key takeaways here are the attribute that defines the class to be an extension of the form, and the call to next within the method itself. This is where the chain concept in chain of command comes in, as it is possible for any number of ISV and partner solutions to wrap this method, and each will be invoked in a chain until the base code is called, at which point the execution is unwound and returned to the caller. In this example, I'm adding code after the core call and updating the UI based on a custom enum value I added in my extension project. We will talk more in detail about chain of command throughout this talk, so don't worry if it's not super clear at this point yet. A core part of any solution is data, so it's important that we provide the ability to extend tables in Dynamics 365. Let's walk through some of the options available for table extensions. As with forms, much of what we support from a metadata perspective is additive. We can add new fields, new indexes, new relations, even new fields to an existing field group. In terms of changing the table metadata itself, we can change the label of a field, change if the created or modified fields are included, and change the EDT of a field, but only to a derived EDT of the base type. Essentially, you can make the field to be more specific, not entirely change the data model. The creation process is identical to that of the form example. You will select the table you want to extend and select the Create Extension menu item. Assuming you have a project already defined in an extension package, you will now have the table extension defined with a default name of tablename.extension. As I was warning you about with forms, it is very important that you do not accept this default naming, but instead update it to include your unique partner or customer prefix. You can see here a table extension I created on the FM vehicle table from the Fleet Management Sample project. As you can see, I've added a new field called Barcode and a new index to support this new field. In addition, I can modify the created by and modified by properties of the table itself by setting these values in my extensions. If I select an existing field that already exists in the base model, such as color, the options I have to change are reflected in the property window. I can update the label, help text, country region codes, and EDT. Tables support a large number of events that extension code can hook into in order to have a view into the life cycle of a record. These events largely come in pairs, with preceding and succeeding events raised. Exactly what to hook into will depend largely on what customization you are trying to accomplish. We published the full list of events on our docs site, but just to give you an idea of how they map out, I have copied some of them here. As you can quickly see, the events ending in ing is the event that precedes the method, and the one ending in ed happens after it is completed. So for example, if you wanted to hook some code into the insert method, you can utilize the inserting event to write code before the insert, and the inserted event to write code after the record is already committed. There are more events than this, including a set of events specifically related to data entities and validations that can be very useful. Much like the form event example, when you copy the event code, you can paste it into an event handler class, and the system will wire up the connection based on the attributes. To be clear, this eventing code does not need to be located within table extension class. This is a common misconception. The method signature of these events will often have this signature, with the record being passed in as the first parameter and a generic data event args as the second. Depending on the event, this can be cast to a more specific subclass in order to get event-specific data. Here are some examples of that second argument being cast to a more specific version. The first is the onDefaulting field event. In this case, we are actually being passed a default field event args object, which includes a parm field ID method to get the field being defaulted. The next one is a validated write event. In this case, we get a validate event args object, which has the ability to set the validation result. The full list of events and parameter objects can be found on the docs site under the Extensibility section. Just as with the form object, it is possible to augment existing table methods with pre- and post-event handlers. All the same restrictions we discussed before apply here as well. You only have public access to the table and must access all parameters through the XPP pre-post args parameter. It is possible to create an extension class on a table. The class must end with the _extension suffix. This class must be unique at runtime, so we recommend including this naming scheme. If you are extending both a form and a table with the same name, it would make sense to include the object type in the unique prefix as well. The extension class added will have the visibility to the core object, including protected member variables and methods, and any methods added will show up as methods on the core table object. Here you can see we have added a custom validate method. From the client code, this method appears alongside other base methods. It can be invoked, and the extension code will be called. A new feature recently added via Platform Update 11 is the ability to define display and edit methods on extension classes. These methods must be defined as static methods taking the parameter of the table class. Here you can see an example of a display method utilizing an extension field. When you add a new field to a display group, you can select the static extension class and method as seen here. Finally, you have the ability to wrap existing methods using the chain of command functionality. This allows you to add pre- and post logic to methods with the additional benefit of access to protected members and the ability to add transaction blocks and error handling, which is lacking in the pre- and post-event handlers. So if we wanted to add additional logic to the check account method on the sales table, we could write this extension code. Note the name of the class includes a unique prefix, including the type of object, because I might also have a sales table form extension. I invoke the chain of command with the next keyword, which calls any other ISV or var extensions on this method, as well as the base Microsoft code. Upon returning, I ensure we have not already failed validation. If I did not do this, I would be overwriting the validation done at the lower levels. If it has passed so far, then I can call my custom validation logic. We have examined the ability to modify forms and tables, which alongside classes are the vast majority of where our partners and customers extend the system. We'll examine a few other objects that support extensibility in the system, starting with views. Views are supposed to support much of the same functionality as table extensions. However, currently, the only supported features are additive. You cannot change the label or help text of a field, for example. You can add new fields and new data sources. Note that adding a computed column is also not supported, but is planned for an upcoming platform release. The same naming scheme we have discussed applies to view extensions as well. Since views do not raise events, it is not possible to subscribe to data events. Instead, subscribe to events on the underlying tables. If the view defines methods, it is possible to define pre- or post-event handlers on these as well, with the same set of restrictions. This code example shows it is still possible to modify the return value using these techniques. Views also support the chain of command wrapping feature, which gives you the same ability as in forms and tables to write powerful extension code with access to protected member variables and methods. Data entities support a set of metadata extensions closely related to views. As with views, the changes you can enable through metadata extensions are through adding new features. You can add new mapped or unmapped fields, field groups, relations, and ranges. You cannot change the properties on the actual data entity itself. Obviously, the same rule around naming applies to data entities as well. Data entities provide a wide range of events, much like the underlying tables. Adding an event handler is the same process we looked at earlier. Simply copy the event handler method and paste it into an event handler class hosted in your extension package. Like the table events, these generally come in pairs, with the preceding event ending in ing and a succeeding event ending in ed. This is an example of code that can run after the insert event. Note that the parameters to this method will follow the pattern we saw with table events. The first parameter is generally the table buffer, and the data event args can be cast to a more specific version to get additional details about the event. It is possible to add pre- and post-event handlers on any method implemented in the data entity. Unfortunately, it is not possible to hook into methods that are not already implemented in the base data entity. So if you need to override and implement a new method, it is not currently supported in an extension. We are aware of this limitation and are working on a solution for this, with an expected release of early next year. Obviously, the same restriction applies to these event handlers in that they have public access only, and data is passed to them through the XPP pre-post args parameter. Unfortunately, chain of command is not currently supported for data entities at this time. We do not yet have a firm date as to when this feature will be supported. Let's talk next about enum extensions and what is necessary to add new values to an enum. In order to create an extension and add values to a base enum, it must be marked as is extensible. If this is true, then you can create an extension and add additional enum values to support your solution. Note that the same naming rules apply to enums as well. So why don't we simply have all enums set this property to true and allow you to extend any enum in the system? It was actually a big push from the R&D team in the spring release to flip this flag on over 800 enums in the core application. I think it is informative to understand the logic behind their decisions as to when they could mark an enum as extensible, and or what mitigation had to take place before it could be marked as such. This would be especially useful for ISV partners who are exposing enums and might want to enable them to be extensible as well. The first rule to understand with extensible enums is that you cannot write code that depends directly on the value, such as comparing the values in a greater than or less than operator. The reason for this is that while the base enum values are deterministic and set by the system, the extension values are generated at synchronization time and are not guaranteed to be any specific value. Depending on the other solutions that might be extending the same enumeration, the actual values are environment specific. Here are the guidelines for creating an extensible enum from the product team. This is related to the previous guidelines. Basically, you cannot use the value in any sort of comparison or range. This is why some enums in the core product cannot be currently switched to an extensible enum. because they make use of these comparisons heavily. Think of the status issue and status receipt in the inventory area. Another common issue with enums is they're used in a switch block, and the default case will throw an exception, thus making it impossible for a partner to provide their own value for the enum. Thus, before marking an enum as extensible, it is necessary to ensure any switch statements on the enum are either hookable by a chain of command or have a delegate to allow partner code to hook into the logic. If the enum switch statement is used in a constructor or factory method, the general best practice guideline is to create a set of classes annotated with the sys extension attributes, thus enabling dynamic creation of classes based on the enum values, including extended values from partners. Here is a specific example from the product team. Prior to the spring release, the barcode type enum was not extensible. When the product team went to switch this flag, they found this construct method utilizing a fixed set of enums with an error message thrown if the correct enum was not found. Clearly, this is not extensible. This same code in the spring release can be seen here. This is now utilizing the sys extension framework to get the correct class from the attribute, thus allowing a partner to extend the enum for a new barcode type. They would need to implement their own class, implementing that specific barcode implementation, and annotate it with the new enum value. To support the previous code, the existing barcode classes were annotated with the barcode type values, thus creating a dynamic and flexible mapping between enum values and classes, instead of the static factory method used previously. EDTs are also extensible in Dynamics 365 for operations. EDTs only support a limited number of metadata property extensions. The primary reason most people extend EDTs is to increase the string size of a field. We recently added the ability to change the number of decimals for real types. This is currently only supported for the EDTs amount and amount MST, and only on platform update 11 or greater. We'll be adding additional EDTs based on customer feedback. We'll just touch briefly on query extensions. Query extensions support the ability to add ranges or embedded data sources, which can effectively change the query selection logic. You can also add fields to the query from the existing data sources or new ones you have added via an extension. Menu extensions are a way to inject your own structure into the application. You can extend both menu objects as well as menu items. At the menu level, you can add additional sub-items as well as hide existing menus or menu items. This way you can hide existing functionality and replace it with a new menu item pointing to your solution. Menu item extensibility allows you to point the menu item to a different object or report, as well as change the label and a handful of other properties. Security roles and duties also support extensibility features, albeit somewhat limited in scope. You can extend security roles and duties, but the only changes possible are adding new duties or privileges. There is no removing or modification possible. Let's talk about reporting solutions. First, the bad news. We have not figured out how to make SSRS reports extensible in the true sense of the word. There is not currently a way to simply right-click on an SSRS report and extend it in your own package with your own data and designs. However, we have many of the necessary components for a reporting solution in place. We can extend the tables necessary to add new data elements to the system, as we discussed previously. We can extend the data provider class that populates the necessary data set with the new data elements. And we can extend the menu item and/or report controller class that launches the report to point to a custom report. The custom report itself will be a copy of the original report with the extension-specific changes added in. This is a depiction of the different models in play. The application suite hosts the original table and report data provider class. We have a custom model. This could be an ISV or a var model, which has appended new fields via a table extension, and subsequently wants to display these on the report. The report data provider is extended to query the new fields and populate the data into a custom report that was copied from the standard base report. At runtime, this report is executed, and the customer sees the new fields as they would expect. Here is a simple example of customizing a report via extension. I want to add the charge description to the Rentals by Customer report in the Fleet Management sample application. First, I extend the TNP FM Rentals by Cust temp table, which is used as the data source to the report. Adding the new field, I will populate with data. Next, I duplicate the report in my project, which creates a copy of the actual SSRS report. Now I can make the modifications to the SSRS report that are necessary for my solution. In this case, I will add the charge description field from my table extension. Finally, I can create a class to host my event handlers. I have added a post event handler for the construct method of the FM Rentals by Cust controller class and did a quick swap of my custom report for the default report that would typically be running. This is how my custom report will be executed instead of the base report. I've also added a post handler to populate my newly added charge description field. This specific step might vary depending on exactly how the report is populating the data source. Finally, we can run the report and see our new data and design. In the original report, these charge descriptions were not present. Finally, we have labels, which is possible to extend with label extensions. Label extensions can modify existing labels in the system as well as add new ones. We also support the ability to add new languages to existing label files. When you add a new label to the system, a wizard will prompt you for information. To build an extension on an existing label file, you just need to use the naming convention of original name _ extension. It is possible to have multiple extensions on a label file. In this case, you can append an integer to the extension string, such as extension 1, extension 2, etc. This wizard will also allow you to add new languages. Unlike other extension objects, label files will not show you all the existing elements of the overlayered object. It is essentially just a blank label file. You will need to go in manually and grab any labels you want to override in the extension and copy them into the label extension. Here I have grabbed the label ID for red from the Fleet Management label file. With this setup, when I run the Fleet Management application, I can see the changes to the red color show up when I run the system under the US English localization. I can also add a Spanish localization extension to this label file and view a different label string when running the application under a Spanish localization. We have examined code already throughout this talk, but now we will focus on the capabilities in X++ to augment and extend classes. Note that much of this applies to forms and tables as well, which have X++ classes backing them. We will look at the following topics in more detail, some of which have already been touched on. Event handlers and delegates are closely connected, and we will look at how these can be used to respond to events in the core application. We will look at the deprecated pre- and post-handler method handlers, and finally dive into the true extension model and the chain of command technology. I'll tackle this question that often gets asked around all these types of extension points. There is no way to guarantee an execution order if there are multiple event handlers or delegates. The handlers are called in an indeterminate order. If you are the only code executing on an environment, it can be tempting to believe you will know the order that events will occur in and make some assumptions about this order. However, as soon as other ISV or partner solutions are added to the mix, your events could be executed in a different sequence. Just keep this in mind across all of these techniques. Events can be raised from forms, controls, data sources, tables, data entities, as well as a number of other areas. These events can be handled by code running in an extension model by copying the event handler method and writing code in an event handler class. Note that this code does not need to be running in an extension class. This is an example of an event handler residing within an extension class of the underlying table. Since the event handler method is static, it does not benefit from the extension capabilities, unless you added static member variables and methods. In general, the recommendation is to create an event handler class that can contain the event handlers and call out to other objects as necessary. The parameters of an event are always generic and must be cast to the specific types. The exact types depend on the underlying object and the exact event being raised. This is an example of a table modified field value event. So we are passed the table buffer as the first argument and a modify field value event args parameter as the second. We have a full list of events and their argument types on the Microsoft Docs site. I recommend using this heavily when building any solution utilizing eventing. So besides the arguments being generic and must be cast to a specific type, you are also running within a static method and only have access to the parameter data that was passed to the event handler. By definition, this means you only have public access to the underlying objects and cannot access the private or protected class members. Delegates are another type of event that can be raised from code. These are typically inserted into X++ classes when it makes sense for partner code to execute within the flow of an existing X++ method. In this case, even the chain of command technology will not help because you need your code to run inside of the Microsoft logic. In this case, the only option is to raise a delegate and write event handler code that responds to that delegate. You can see all of the delegates on a class by viewing that class in Design View. Then you can copy the event handler boilerplate code just as you did with the events in forms or tables. The event handler code can be copied into any class. Again, the mechanism that ties this together is the attribute itself. Depending on the type of delegate, the parameters can be very specific to that scenario. At a high level, there are two major classifications of delegates in the system. The first is a publish-subscribe pattern, where there is no expectation or even possibility of the subscribing code to affect changes in the base code. This is primarily used as an eventing system such that partner and customer code can execute at the correct times over the life cycle of the application. One example of this is the application startup delegates, which provide some events on the application lifecycle. The other major classification is the request-response delegate type. In this, we do expect some sort of response from the partner code, codified through the event handler result reference parameter. Here's an example of requesting the extension code to provide some information in order for the base logic to continue. The pattern here is that the last parameter on a request-response delegate is always the event handler result object. As you can see in the code, this is checked to see if any subscribers have set the value via the hasResult method. In this way, partner and customer code can hook into the base application and make changes in a type-safe and supportable way. Here's another example of a delegate used to get information from the extension code. We talked earlier about extensible enums and switch statements. This is an example of providing the delegate so that extension code can respond with the extension enum values. As such, the event handler result is used to return the result to the base code. Note also that the code has requested that only a single response is valid. Thus, only a single subscriber to this delegate can set this result. Otherwise, an exception will be thrown. As we discussed with forms and tables, you also have the ability to write pre- and post-handler code on any public or hookable method on any X++ code in the system. Hookable is an attribute that can be placed on a non-public method to allow the pre- and post events to be written against it. We have covered this technique in detail. You have the restriction of only external or public access to the objects, and everything must go through the non-type-safe methods of the XPP pre-post args parameter. In general, we believe the chain of command supersedes this technique if you are running on Platform Update 9 or higher. Class extensions are a way to augment X++ classes with new methods and new member variables. From an object-oriented point of view, is a bit like deriving from a base class, as you get that level of access to the extended class. However, the client code does not need to be changed to utilize your new derived class. The new extension automatically augments the existing objects. This can be very powerful, especially when combined with the chain of command technology that allows you to wrap existing methods and write your code before and after. Class extensions must end with the suffix _extension, and they must be decorated with the extension of attribute. They also must be marked as a final class, as there is no option to derive from these. As we discussed previously, it makes sense to include a unique prefix in the name. The name before the underscore extension does not need to exactly match the original class name. The actual mapping is done through the attribute. Any new methods added via this extension class will be visible to client code that has a reference to the extension model. Extension classes can also add a new class member variables. This state can then be used in the extension methods or client code if it's public. A nice advantage that class extensions have is the ability to see protected members, both variables and methods. Private data is still hidden from extension classes, but extension classes now act like a derived class in that they have the same level of access to the protected state. This brings us finally to the chain of command technology, which was introduced in Platform Update 9. This allows you to declare a method in an extension class that is an exact copy of the extended class method. The parameters must match, and if there are defaults specified in the base class, they should not be set in the extended class. This method will allow you to write code before and after the base code, which is invoked via the new keyword next. This next is analogous to calling super in a derived class. It will call into the chain and invoke any other extension code that is hooking into this method, finally terminating with the Microsoft base code. Your extension code will eventually pick up the execution again and can continue after the base code, making use of the return value and performing any additional logic, up to and including changing the return value. This is our canonical example of the benefits of chain of command. You can find the MSDN Channel 9 talk introducing it using this example, so I won't talk about this in too much detail. Note that in calcamount, we call the base code and then act upon the return value to add our custom logic. In the post method, we see the primary benefit over the pre and post event handlers, in that we have a complete view of the execution and can wrap the base code in a new transaction block to ensure our logic executes with the same transactional guarantees as the base code. In this case, we ensure the log only executes if the posting was successfully committed, since any error will throw an exception and cancel this block of code. Just to give you a visual of what is occurring, when you extend a class and write some chain of command code against a method, the chain in question looks much like a derived class calling super, as we discussed. You have an opportunity to write code before the base code and after, including wrapping it in a transaction or try or catch block. Where it gets much more interesting, and where the name comes from, is when there are multiple extensions on a single method. This is exactly where the classic overlayering model breaks down, as the VAR or customer must manually integrate source code across different ISV and partner solutions, including base Microsoft hotfixes. In the chain of command world, each of the customizations is isolated to their own model and has no direct source code level interaction. They communicate based on the well-defined interfaces of the method and class boundaries. Note that, like the event handlers, it is impossible to know the exact order a chain of command execution set will operate in. The only fixed point is that the original method will be the last step in the chain, after which the calls will unwind back up to the caller. Note that there is often a request to skip the call to the base level code. As of right now, this is a hard restriction that we do not allow. The compiler will fail if you do not have the next call at the base level of the method, meaning you also cannot create if statements to conditionally call the base level code. You should assume for now that it is a requirement to call next. Note that we have recently introduced a new attribute called replaceable in Platform Update 11. If this is applied to the base method, then it is allowed to skip calling next. Effectively, we are saying this method contains code that can be completely overridden by partner code. We are still exploring exactly what methods this makes sense to apply to. For now, it is safe to assume you must call next for any extended method. We have now taken a fairly exhaustive look at the extensibility features in Dynamics 365 for operations. So what happens if your solution has requirements not fitting into any of the techniques I have described over the past hour? In this case, we need to have a discussion about intrusive customizations. Since AX as a platform has been so flexible in the past, we find that the expectation is such that any changes and modifications to the core logic of the system should be allowed. Moving forward into hard sealing of the application, this will not continue to be true. Some of the things we are not likely to allow are changing the method or type definition of our application objects. These define the contract of the system with our partners, and as such, allowing them to be mutable is very challenging to support in a cloud-first world. We are also not likely to support direct embedded SQL changes or inline code, as this is exactly the overlayering model we are moving away from. The general guidelines are to be additive in nature and to not break encapsulation or object models. So what happens if what you need is not currently supported in Dynamics 365 for operations? Assuming it is not an intrusive customization and is something that we are willing to add to the system, then you will need to reach out to Microsoft and file an extensibility request. We are still exploring how best to triage and manage these requests, but right now the two best avenues are to submit a connect request, which is published on our docs site. The other approach that has proven successful, assuming you are working on a project with the fast track team, then you should have a solution architect working with you. Getting those extensibility requests to this person is usually a good starting point for this discussion. We can triage and either help you move to pure extensibility or get the requests into the extensibility backlog. So what types of requests are we likely to accept? You can see the categories of requests that we typically accept on the screen. Obviously, moving Enums to extensible Enums is a popular one. I walked you through some of the criteria we have to go through on our side to ensure this is possible. Many of the other areas involve refactoring or exposing code so that partners can plug in their own code at the appropriate points in the application lifecycle. Adding delegates, exposing members, and ensuring methods are hookable are all designed to get partner code out of overlayering and into an extension model. Obviously, there are some things that are simply not possible right now, such as marking entities as OData enabled by an extension or adding fields to an existing index. These types of requests fall into the extensibility platform itself and have to be built in a manner that ensures the application continues to grow in a safe and efficient manner for all customers and partners. So that's all I had on the extensibility topic. I hope you learned something from this talk. I have tried to use it to cover a pretty wide swath of functionality in the extensibility space. As you can see, we have a lot of capabilities to help you move your code from overlayering to extensions. Obviously, there is more we are doing in this area, but this tech talk at least represents the state of the art as of October 2017. If we have time, I'm happy to take a few questions.
Isaac, we have two questions in the window.
Okay, I can see we have a question around enum extensions. So enum extensions works with platform. Actually, I forget what platform update it's added, but it does not require platform update 9 or higher. Enum extensions were supported in some earlier platform than that, and so it would support, I forget, platform update 6 or something. You can support enum extensions. So we have a question around the label extensions. If like how do we manage ISVs? Because they could have like sys underscore extension X where X is some number, and so yeah, you would have to the var that would be implementing that would have to manage those different ISVs that were coming with those label files and give them unique numbers as they're doing the work that combines them. All right, so that would be the work of the var that finally does that, gives that final naming on those extensions. Okay, thank you all for attending. I'll pass it back over to Otto to close out the stream.
Excellent. And with that, that concludes today's session. I've added a link to the survey there in the messages panel. We certainly appreciate feedback that we're able to gather via that method about what you thought about today's content and what you'd like to see in the future. And again, everybody can access the web conference recording via the same registration link that you used to attend today's live broadcast. With that, that concludes today's session. Hope everyone has a great day.